Our topic for today is going to be Unit 1.8, which is Day 1, which we are going to kind of split into a couple parts. But the first part that we're going to discuss is factoring quadratic expressions. We're going to take a look at how we can take a quadratic expression and factor it so that we can use it in an appropriate way. So the first thing that we normally look at is what our objective is for today. And so our objective is to factor a quadratic expression to determine its binomial factors. And we were just kind of working with factors. And we kind of understand that factors are zeros. So what we're going to basically kind of move into is, factoring things so that we can find their zeros rather than having to rely only on dividing polynomials. So a couple of the things that we need to look at, and some of the things that we need to remember, not necessarily vocab words, but just some of the general kind of feel for what a quadratic is. So a quadratic is an expression with a degree of 2. So whenever you see something with the highest degree of 2, so x squared plus 3x plus 2 would be a general example of a quadratic equation or a quadratic expression where the highest degree term is 2 or has an x squared. Now, kind of going off of that idea, the question is how many factors should a quadratic have? And the answer to that is 2. And if you kind of look at what this is, so what we have is if I have x plus 2 times x plus 3, and if I was to have you FOIL that, you would end up with x squared plus 5x plus 6. And so the idea there is that when we have a quadratic, we're only going to have 2 factors. We're going to have one factor here and then another factor there, because you think about it, x times x is going to be x squared, and that's quadratic. And when we look at that situation, just kind of how I showed you there, factors and zeros kind of go hand in hand, and so how many zeros should we expect a quadratic to have? Well, that's kind of tricky in some cases because, we're going to say 2, but we're going to kind of reference or preface that and say it's up to 2. Now, you could have less, so technically speaking, a quadratic function could have 0, it could have 1, or it could have 2 different zeros. Doesn't always guarantee that we're always going to get 2, but the possibility is still there for a quadratic. Now, let's remember some of the things that we have done before. So if I was to ask you to factor some of these monomials, what we'd basically do is we would write all of these things out in terms of what their factors were, and this kind of goes back to the whole prime factorization. So if I have 4x to the third, and if I was to prime factor that, that would be 2 times 2 times x times x times x. We were just writing out all those factors like we've done before. 12x squared, 2 times 2 times 3 times x, writing out all those factors there. And then with 8x, we would have 2 times 2 times 2 times x would be all of my factors for 8x. Now, on the other side of this, if I was to ask you what is the greatest common factor of all of those, and we were to look at these individually and kind of look at them together, and we've kind of done a little bit of this before, but what we can notice is that each one of these share at least one 2, they share a second 2, and they each share one x. And so when we're looking at greatest common factor, maybe we could see it between the numbers and the variables, but our greatest common factor is 4x, because we get 2 times x, and we can simplify that to 4x. So the idea is that we kind of have to remember these greatest common factors, and then we have to kind of remember how to find these greatest common factors with different things. Alright, so the next topic that we're going to kind of review is factoring using greatest common factor, and this is kind of something that we've already done before. So we're going to look at 6a squared and 8a, and we're going to say, okay, what is the greatest common factor between both of those? So we're going to look at the numbers, and then we're going to look at the variables individually. So between 6 and 8, the greatest common factor is 2. And then they both share at least one a, so my greatest common factor would be 2a. Now remember, when we were factoring using greatest common factor, I would bring out my greatest common factor in the front, and then leave everything else after I divided that away. So after I remove a factor of 2a, from 6a squared, I'm left with 3a, and then minus 4, because when I remove that factor of 2a from 8a, the variable gets removed, and then we divide that away and we get 4. So this would be 2a times 3a minus 4 would be something that I could factor completely. Now we can do that same thing with the next example. So we find the greatest common factor between those three terms. So we have 9, 6, and 12, so the greatest common factor there is 3. And then we look at the variables, so x to the third, x to the second, x. They all share an x, so my greatest common factor is 3x. Create my parentheses and then kind of keep things that are left over. And so that gives me 3x squared minus 2x and then plus 4. Now this is something that we have done previously, so if you need to reference that video, you can always go back to the video that's on the channel, and then you could find that as far as factoring using greatest common factor. But the idea here is that we just want to make sure that we remove all these greatest common factors before we try to do anything else. And if you notice here, this right here, that's now, or this entire thing is a quadratic expression. This one here, it was quadratic because it had that a to the second, but we kind of factored it a little bit differently so that we could tell, where zeros are and things like that. So if I asked you, okay, what's the 0 here? Remember, we could set that equal to 0 and we could figure that out. Here, we still have some more work to do, and that's kind of what we're going to be working on in this video. And so what are we trying to do now? Well, given a particular quadratic expression or quadratic equation, what we're going to try to do is we're going to try to refoil it. So the first thing that we did, we've kind of worked with these type of things, these type of binomials, and foiled them to give us this equation or this expression. But now what we're going to do is we're going to take the expression or the equation and then we're going to unfoil it and we're going to kind of put it back in parentheses form. So this is kind of a way that we can say, or kind of a hint that we can say, we're going to undistribute. Because foiling, I told you, is all about distributing, and so we're going to just try to undistribute what we have so that we can get this into what we know as factored form. And so we kind of looked at this already, and this is factored form. And we can kind of already tell where we're going to go with this is because we've already been working with factors, and then we're going to try to find the zeros from these. So it's very important that we kind of get in this habit of doing this. And if you go through this, you can see that there's a few steps to this. Mainly our biggest issue is going to be identifying b and c. And if you look at this polynomial up here, you have obviously the a, the b, and the c all reference coefficients. So we're really going to be working with the coefficients, not kind of worrying about what the variable is that we're using at the time. Okay, so what we have is there's different varieties of what we can have. We have polynomials that we have listed here, and each one of these, if you notice, have a different last term. And so we always look at the last term, and I told you that we're going to be referencing coefficients in A, B, and C. Well, what we're going to look at is we're going to look at specifically C. C will kind of be the guide to everything that we're going to do here, and we either have a positive ending or we have a negative ending. And so what that means is that we're either going to multiply two numbers. If you think about the way that we multiply, the way that we were to have our foiling method, that we always multiplied the last two numbers. And the whole idea is that we multiply the last two numbers and then we add those two things together. So when we look at the last value, we either have positive or we have negative, meaning that you either multiply two positive numbers and get a positive, multiply two negative numbers and get a positive, and then you either multiply a positive and negative and get a negative answer. Now that's going to lead us into our parentheses. So the whole idea of what we're going to do is we're going to try to remake parentheses. And so we're going to come into one of these two types of situations where the signs are going to be the same in both of our factors, or they're going to be different. And we can really tell that by that last term C, that if that last term is positive, they're both going to be the same. So it's going to have the same signs. And if it has a negative ending, they're going to have different signs. And really what that comes down to is the fact that when you multiply, if they're both the same sign, they're going to end up always being positive. But if they're different, it's always going to end up negative. And so we're going to use that and reference that a little bit later. Alright, so here's our first example. Now our first example is we're given a trinomial in the form of ax squared plus bx plus c. In this case we're looking at x squared plus 5x plus 6. So the idea is what we're going to try to do is we're going to try to identify c, and we're going to try to identify b. And so if we look at this, c is equal to 6, and that's right here, so this is c. And then when we try to identify B, B is equal to 5, which is this piece right here. Now if you notice, what I did is I incorporated that addition, which is going to tell me whether these values are actually positive and which ones are negative, because I told you what that allows us to set up. What that allows us to set is our parentheses, because the idea is that we kind of will at least try to remember, or at least try to understand, that what we're going to try to do is we're going to try to make two sets of parentheses. So each and every one of these sets of parentheses is going to start with an x. So the idea when we have this coefficient of 1 is that we know kind of what this is going to look like already. So we have x here and we have x here. Now we don't know whether it's going to be a plus plus, a minus minus, or a plus minus, or a minus plus, but the idea is that we can get that information from C. And we can also get that information to B. And so if we look at this, the idea is the C, which is 6, is a positive 6. So what that tells me is that my operations are going to be the same. So they're either going to be plus plus or minus minus. Now I can look at B's sign and say, okay, well B is positive, and the only way that this can be positive is if the only way that they can be, if they're the same, the only way that they can be positive is they're both positive. And so the idea behind this is from B and from C, since B and C are both positive here, we can know that they're both going to be the same, because remember, C tells us what the operations are going to be. They're either going to be the same or they're going to be different. And then B tells us whether they're going to be positive and negative. And we'll get into a little bit more of that as we go along. But the idea here is that we have these two situations here. So we have 6 and then we have this 5. So C is positive, so that means they're both going to be the same. B is positive, so that means they're both going to be addition. Now the idea here is what we're going to try to do is we're going to try to find factors of C here. Now factors of C, so if we take 6, different factor pairs that could multiply to 6 would be 6 and 1 and 2 and 3. Now those are the only setup that we have for 6 and 3, and they can be alternated. But the idea is what we're trying to look at is we're looking for a factor pair over here on step 3 that they add up to B. So the only factor pair that adds up to B here is 2 and 3, because 2 plus 3 is going to be 5. Now take a look at how this works. So this is going to be x plus 2 and then x plus 3. So what we are doing here is we're looking at 6. So 2 times 3 is going to give us 6, but also positive 2 plus positive 3 is going to give us the positive 5. So we're looking for factor pairs of C that will add up to become B. And so when we look at that, we're trying to just write out factor pairs. And so we're going to look at some more examples of that in just a second. So with our next examples, we're looking at a little bit more. Now again, remember, our most important pieces of information are B and C. Those will tell us what kind of things to look for with our parentheses. So we're trying to set up a FOIL problem. We're starting to set up pre-distribution. And so whenever we start these problems, we always have to make sure that we have things in standard form. So we're going to just rewrite this, x squared minus 7x plus 6. And so we know that C is 6. And we know that B is negative 7. And so what we're going to look for here is we're going to look for factor pairs of 6 that combine to give us negative 7. Now those could be a mixture of positive and negatives. We don't know yet. Now the guide that I gave you kind of starts with, okay, well, we know that we're going to have two binomials here, and they're both going to start with x. We just don't know if they're going to be x plus or x minus. And so we can look at C. C is positive, so that we both know, or we know that our operations are going to be the same. Because the only way that we can get a positive out of those is if they're both positive or they're both negative. Now when we look at B, B is negative. So what that means is the only way to multiply two numbers to get a positive and then add them to get a negative is if they're both negative. And so that's kind of what we're looking at here. That's why we're using B and C. They kind of tell us whether things are going to be both positive or both negative if C is positive. Now what we're looking for is we're looking for factor pairs of 6, 1 and 6 and 2 and 3. We're looking for which one of those combine together to give you 7. And the only factor pair that does that is 1 and 6. And so if we take a look at this, we can just plug in these numbers now. We would have x minus 6 and x minus 1. Now the idea behind that is if I distribute this, x times x is x squared, minus 6 times x is minus 6x, and then x times 1 is negative 1x, and then negative 6 times negative 1 is positive 6. If I combine those together, x squared minus 7x plus 6. And that's originally what I started with. But the idea is that we can kind of go through this so that we don't have to look at that. But the idea is we're looking for factor pairs of C that combine to give you B. Now, there's different ways that we can do this. This is one approach. You don't necessarily have to worry about C being positive or negative. You're just looking for factor pairs of that number that combine to give you B. So let's look at one other example here. So the first example, we have to make sure this is in standard form, which this is in standard form. But the problem with this one is that we may or may not have common factors. And so we want to try to eliminate any common factors so that we don't have to, have such a more difficult problem than we need to. I recognize right here that I can divide each one of these by 2, so my greatest common factor is 2. They all don't share an x, so there's nothing that I can remove. So what I have left over is 2 multiplied in parentheses by x squared minus 5x minus 14. Now this one's going to be a little bit more tricky. Now I can kind of ignore this 2 on the outside and just kind of focus on this polynomial on the inside here. So what I'm looking at is I'm identifying C. So in this case C is negative 14. And then what I'm also looking at is that B is negative 5. So I'm looking for factor pairs of negative 14 that will combine to give me negative 5. Now obviously what we're trying to understand here is that since C is negative, one of those factors has to be positive and one of those factors has to be negative. So if I was to set up my parentheses to get ready for this, I would have 2 on the outside because that was already there, and then I would write my 2 parentheses. And so I know that I'm going to have an x plus something and I'm going to have an x minus something. And the reason that I know that is because that C is negative. The only way to get a negative answer when you multiply, one is positive, one is negative. Over here, that's what I was trying to explain here, is that the only way to get a positive answer on the end is that if they're both positive or they're both negative. And so one easy way that we can do this is writing factors of 14. So factor pairs of 14 would be 1 and 14. We would have 2 and 7. And then those would be it. And so we need to look at which one of these factor pairs combine to give us negative 5. Now the easiest way to do this that I've found that when I do this is I'm not necessarily looking for which ones add up to be negative 5. Since I already know that this is negative, I want to know what the relationship is between them. And so what I look for is I look for a difference of 5. So which one of these two factors are separated by only 5 values, and it's 2 and 7. Now the problem is we need to determine which one is going to be positive and which one is negative. And since if you kind of remember, we're going to be combining these middle terms together. And so we look at what B is. B is a negative value. B is negative 5. So what that means is if you're adding two numbers together and your answer is negative, the bigger of the two numbers needs to also be negative. And so the idea is that our final answer is, and we fill in our parentheses, we're going to have x plus 2 and then we're going to have x minus 7, because if you think about adding those two numbers together, negative 7 plus positive 2 gives you negative 5 as an answer. So the idea is what we're going to try to do is we're going to try to undistribute by looking at what we can multiply together and then add those things together too as well at the end.